Okay, in this module we're going to talk about multiplying radical expressions. And there's a direct relationship between this and what we learned in the very beginning about multiplying polynomial expressions. Remember, your basic unit is a monomial. It's one term. So if I take a monomial and multiply it to a monomial, my answer, my product, should always be a monomial. So remember, back way when, if you had 2x and you multiplied it to 3y, well, 2x is a monomial. It's connected by multiplication. 3y is a monomial. It's connected by multiplication. And when you multiply those terms, you get 6xy, which is also a monomial connected by multiplication. Well, that's how radical world works. When we multiply radical expressions, we're going to multiply a monomial times a monomial. There's no paperwork. We're going to multiply them. We're going to get an answer that's a monomial. The only catch is, after we get our product, our answer, we got to make sure it's in lowest terms reduced. The rule of thumb is what's on the outside of the radical gets multiplied what's on the outside. What's the inside gets multiplied what's the inside. So when you multiply radical expressions, it's like multiplying 2x and 3y. You multiply the coefficients first, and then you're going to multiply the variables. Well, today we're going to multiply the coefficients first, and then we're going to multiply what's inside the radicals, the radicands. All right, so let's look at our first example. We have square root of 8 times square root of 2. Well, everybody think about this. If it was just good old 8 times 2, you would say 16. Because it's square root of 8 times square root of 2, when you multiply the 8 into the radicands, that product is going to stay inside the symbol. So the square root of 8 times the square root of 2 is the square root of 16. That was easy, right? Now the question is, can you leave the answer square root of 16? No, because 16 is a perfect square, and we all know the square root of 16 is 4. So see how simple that is? You're going to multiply together and then simplify or reduce. If you look at my next example, I have the monomial 4 cube root 3, and I want to multiply that to negative 2 cube root 9. Those are monomials. They're connected by multiplication. You're going to multiply the coefficients first. So 4 and negative 2, if we multiply, it gives us negative 8. Then you're going to multiply the radicands. You have a cube root 3 and a cube root 9. Well, 3 and 9 is 27. So now I have a cube root of 27. But can I leave that answer? Can I leave negative 8 cube root 27? No, because 27 is a perfect cube, and we know the cube root of 27 is 3. So that gives us negative 8 times 3, which is negative 24. So it's real simple. When you multiply a monomial times a monomial, your product, your answer, is a monomial. When we're dealing in radical world, you multiply the coefficients on the outside together, and then you multiply the radicands together. And then you have to make sure your final answer is reduced. The other thing I want to point out is, remember, with multiplying, terms do not have to be alike. We just multiplied a cube root of 3 and a cube root of 9. Those are not like terms, and that's okay. Because in multiplication, your terms do not have to be alike to multiply. All right, let's go to the whiteboard and try a couple more expressions.